Hello guys, this is Prime Concept. Now I'm here to continue analyzing the concepts under optics. If you have been following my channel, if you are subscribed to my channel, you would notice I've been dropping videos from the very first part of optics. We considered reflection at plane surfaces. We considered plane mirror. Then we also considered reflection at curved surface. We introduced it, we explained what a curved mirror actually is, and we mentioned that curved mirrors are gotten from curved parts or curved shapes. And an example of a curved surface is a spherical surface. So we mentioned that we have two main types of curved mirrors for the sake of this course, because for those that are watching from Nigeria, in the US, UK, and for the sake of your physics at this level. So we consider just two types of curved mirrors, which we mentioned that they are the concave mirror and the convex mirror. Now, we went on to explain the terminologies that are associated with mirror or curved mirrors. We mentioned the pole, we mentioned the center of curvature, we mentioned the principal axis, we mentioned the focal length, we mentioned the focal point, and so on. We explained all these terms. We also further explained the rules, because we mentioned that if an object is placed in front of a mirror, that object would form its image. Now, depending on the location of the object, the position of the image would vary. The position of an image is not fixed, so it will be dependent on where the object is located. Now, what we want to look at in this particular video is when you place object in front of a concave or convex mirror at certain positions, where will the image be formed, right? That will be the topic of this video. In order for you to be able to locate the positions of image in front of a mirror, you need to understand the rules that governs that location. And I mentioned in my previous video that we have 4 rules that governs the location of image. I will just recap on those rules. Now, number 1, I mentioned that when you have rays entering your mirror that are parallel to your principal axis, when those rays hit your mirror, it will reflect through your focal point. So it is 1, which I mentioned. Number 2, I mentioned that whenever a ray enters through your focal point, when it hits your mirror, it will reflect parallel to your principal axis. Number 3, I mentioned that when a ray enters through your pole, or when a ray hits your pole, the pole of your mirror, then that ray would come out in such a way that the law of reflection is obeyed. Then number 4, I mentioned that when a ray passes through your center of curvature and hits your mirror, it reflects in the same direction. So these are 4 rules that I mentioned. In this video, I'll be applying those rules to locate positions of various objects or images that are formed on the mirror, right? So that is what we'll be doing in this video. So I would write location of images, image position using ray diagram. So we're going to use rays to locate the position of images that are formed. So in this case, we are considering our concave mirror. So that is what we'll consider. Now, the first position we want to consider, number 1, is when object is at a very far point. So we want to say is at infinity. You know that infinity simply means something that is very far, such as you're trying to view the image of the sun. The sun is the sun is at a very far distance. So the sun can be considered to be coming from infinity, right? So infinity means something that is very far. Now, when you're studying physics, infinity is usually denoted under ray concepts with parallel lines. So when you see parallel lines, it simply means that the object of that parallel line is at a very far point, is at infinity. So that is what we want to consider. So say this is my concave mirror. This is my concave mirror, and this is my principal axis. I will try to draw straight lines because I'm using freehand. And this is my focal point, F. This is my center of curvature, C. So I would apply one of the rules which says if a ray passes through your focal point, it would reflect parallel to the principal axis. So let me try to get a good line. So when a ray enters through your focal point F, if it is reflecting, it will become parallel like this. So it will come out parallel to your principal axis. Now, the second rule, like I told you earlier, that for you to locate an image position, you need two rules. You can use two rules. You need a minimum of two rules, right? So I'll be using just two here. Now we have another one which says when you have a ray entering through C. So let me do it a parallel line like this. So this is a parallel line. And when you can see these two lines are parallel, even though they are not drawn to scale. Now, when you have a ray that enters through your center of curvature, when it is coming back, it reflects through the same direction. Now, where will your image be formed? Your image will be formed where your two reflected rays intersect. Now, this is one reflected ray, which you can see, then this other reflected ray is still here. So this is their point of intersection. So if you check it, since it is down below, it means that our image is actually formed facing downwards, right? So where is our image formed? Our image is formed at point what now? At point F, the focal point. So now we want to list the properties of this image. Properties of this image when your object is at infinity. What are the properties, or what is the nature of the image? Now, number one thing you should know about the image is that the image is at F. The image is formed at the focal point. That is where the image is formed. Now, number two thing you should know is that the image is inverted. The image is what? Is inverted. You can obviously see it's down, it's facing down, so it's inverted. It's inverted. Now, number three thing you should know is that the image is real. Why is the image real? Very simple. Anytime you have images formed on this side of your mirror, that is in front of your mirror, it simply means that that image is real. But if the image is formed at this side, which is the back of your mirror, it simply means that the image is what? Virtual. So in this case, our image is here. This is our image, which is formed in front of the mirror. So the image is what? Real. And I also told you in my previous video to note that whenever you have a real image, it must be inverted. So you don't have real images and erect images. It should be real and inverted, or it should be virtual and erect. So these two terms go together, right? So this is what we have. And then number four, the image is diminished. The image is what? Diminished. What does it mean? It simply means that the image is smaller than the object. So we usually call it a point image. So it means relative to the object, the image is really very small. So the image is diminished. So these are the properties of the image formed when your object is at infinity. Now, what is one of the questions you can see from here? They would ask you in exam. They say, when an object is coming from infinity in front of a concave mirror, where would the image be formed? So of course, then they will ask you to tell them the nature of the image that is formed. So you can quickly describe that. The image is formed at F, the focal point. Then you describe those properties. So I'll drop this so that we can go to point 2. So the next one I want to consider, I will consider just two in this video. Then in the next video, I'll consider another two. So when object is behind C, what is C? Our center of curvature. Now, when your object is located behind your center of curvature, where will the image be formed? So let's quickly do that. So I have this. Okay. So this is my pole. This is F. This is C. So if my object is behind C like this is where my object is, at the back of the center of curvature. Now, we always indicate object using straight lines above. We don't draw objects facing down. We draw them facing up. Even though if you draw facing down, it won't be wrong, but you confuse yourself. So the standard is you draw an object facing up with an arrow like this, right? And you let it start from your principal axis. Now, any other ray you are drawing from this object, it will be ideal to draw them from the tip of your object. Don't draw from the center, from the tip of your object. Now, let's do that. So first, I'll use one of the rules which says if I have a ray that is parallel to my principal axis, you can see this ray is parallel to my principal axis. When it hits the mirror, where will it bounce through? You are very correct. It will bounce through your focal point. So it will come like this. So it will come this way, pass through your focal point, right? Yes. Now I'll use another rule. Let's say a ray that is passing through your focal point like this. And when a ray enters through your focal point and it hits your mirror, if it is coming back, how does it come back? It comes parallel to your principal axis, right? Very correct. So this is what we have. So if it is coming back, you'd have something like this, parallel. So even though my lines are not very straight, so you can see it's coming back parallel. Now, where do they intersect? This is their point of intersection, right? So if you check it, this is what you have. Since it is below, that's why it is still pointing down, because it is down. Assuming it was up, to be facing up. But since it is below, it must point down, right? Now, if you look at this, we can outline the properties of this image. The properties. So number one property you should know is that the image is formed between C and F. So image is between C and F. So image is formed between the center of curvature and the focal point. What is another property you can observe from this? Very correct. The image is actually what? Inverted. Thank you. So number two, image is inverted. So now, of course, you should know when an image is inverted, automatically that image should be what? Real. Very correct. So now the image is real. Why is it real? Because it is located in front of the mirror. So image is real, right? Now, number four property we want to still find out from this is that the image is smaller than objects. So you can say the image is diminished. So what it means is that the image is smaller than the object. The image is smaller than the object. So meaning that the image is diminished. So these are some of the properties you would observe from this. Now I will stop this video here so it doesn't become too long. In the next video, I will be uploading for the next location of the images. The next one will be when my object is at C. Where will the image be formed, right? If you have watched this video up till this point, please do well to hit the subscribe button. Subscription is free. Subscription is just so that YouTube can actually notify you whenever I post new videos. They will inform you so that you'll be among the first persons to see it, right? And benefit from it. So whenever you watch any of my videos, do well to hit the like button, comment, and share with your friends so that they can also benefit from what you are getting from, right? I believe this is very clear to you. Thanks for watching. This is Prime Concept.